All right, welcome to part 3. We're just going to, again, continue right where we left off. So we need to write this section of code for what happens when we are pressing movement input, but we're currently hugging a wall. So we actually want our component to handle this input for us. So we're going to drag this guy in, and we need to make a function in here for handling our movement input. So let's go back to our BP wall hug component. And then on the left, let's add one more function. I think this is the last function we need, but don't quote me on that. And we're going to call it handle movement input. And then let's see, we want this guy to take in the same values as the other one. So we're going to take in a float for the scale. And we're going to take in a Boolean value for right. All right. So essentially what we want to do is we want to make it so that the player can only move like perfectly to the left or perfectly to the right. So to do that, well, let's first of all make sure we are currently on the wall, because if they press input and we're not currently on the wall, we don't want to do anything. So let's do a switch statement here. And then we only want to do anything off of the on wall. So the first thing we want to check is that our wall normal is something valid. So let's drag this in. If you remember, this is the wall normal that we get from the tick function. So each tick, it updates this value to be the normal of whichever wall is behind us. So if there isn't a wall behind us, for whatever reason, we obviously don't want to do anything because we're about to end the wall hug. So let's just make sure that this is not 0. So we'll say vector is 0. And of course, we want to do a not Boolean, so we want the opposite of that. And then we want to do a branch. So we're going to hook this up to on wall. Make sure you hook it up to this one, because again, we only want to do this if we are actually on a wall. And then we want to check the input type. So let's see, or let's right click and say get right to check. Sorry, I might need to compile. You won't actually be able to see these values until you compile. So that's why I randomly compile sometimes. So we'll say get right, and then we'll do a branch off of this. And we're going to hook this up to the true, right? Okay, so what we're saying here is left and right input being used? Because remember, this is left or right, really. So if left or right input is being used, then we actually want to move the character. Otherwise, we don't really want to move the character. But if, for example, they press the down key, we want to actually stop the wall hugging. So if, for example, if I'm up against this wall here and I press S, I want to come off the wall, right? So we want to be able to allow them to come off the wall by pressing F. But if they press W, we just don't want anything to happen at all because they can't move in that direction. If you don't want them to come off the wall by pressing S, then feel free to skip this little part, but for my tutorial, I do. So in the false case, we just want to handle that. So we're going to right click and say get scale, which again is just this guy over here. And so if this is less than 0, so normally you type float less, but of course now we have to type just less. So if this is less than 0, I'm actually going to use less than negative 0.1, just so there's a little bit of leeway. And we'll do a branch. So if it's less than 0, essentially, then we want to, or then we can say, okay, they're pressing S, and we want to end the wall hug. So we'll say, where's our end wall hug function? We'll just call that guy. It's kind of a rare case, just if they're pressing S. But most of the time, they're going to be pressing either A or D for left or right. So in that case, we want to move them perpendicular, or I guess parallel. We want to move them parallel to the wall. So to do that, we can take the wall normal and we can cross it with the world's up vector, because we're technically moving them parallel to the wall, but that's the same as perpendicular to the wall's normal. So since we know the wall's normal, we can calculate the direction that's parallel to the wall. So we're going to do the cross product. If you don't know what the cross product is, essentially, long story short, is if you cross two vectors, it will return a vector that is perpendicular to both of those vectors. If you have no idea what I just said, you can go look at my tutorial on, it's called Game Math Essentials. It's on my channel. It covers cross products. It's very simple stuff to understand, but if you don't know it, I highly recommend watching that tutorial because it covers a lot of really useful math stuff, including the cross product. But anyways, we're going to take the cross product of the wall normal and the vector up, which is just the world up vector. and that's going to give us a vector that is perpendicular to the wall's normal on the horizontal plane. And then we want to normalize this. Again, if you don't know what normalize is, just go ahead and check out that Game Math Essentials tutorial. It will explain all of it. But it just makes it so that the vector is a unit vector with a length of 1, since that's what we want in this case. And we're going to say owning character add movement input in this unit vector direction. And then for the scale, we're going to pass in whatever the scale is. So we'll just say get scale, and that's going to allow us to move left or right. And we can hook that up like so. And there we go. Okay, so let's give this a try. So I have a feeling we're going to have some bugs here, but does not work. Oh, I probably forgot to call this function. Let's see, third person character. Yes, I forgot. So we will call, what did I call it? Yeah, handle movement input inside of our other handle movement function. And we want to pass in the get scale and get right. Okay, let's try this again. So what we should see here is if you go up to a wall and we press E, you'll see he initially turns around correctly to face away from the wall. And if we press W or S, nothing happens, which is good. And then if we press A, you'll see he starts moving to the left, which is correct. But you'll notice the character actually turns to face to the left, which we don't want. And you're probably thinking, well, didn't we add code to make sure that that doesn't happen? And the answer is yes, but there's still, there's a checkbox we actually need to uncheck inside of the character movement component when we get on the wall to make it so this doesn't happen. But at least for right now, just make sure you can go left and right along the wall. And he should go over this bump thingy, but it's kind of weird because he won't like actually attach to the wall again until you turn around. So it's kind of weird behavior at the moment until we fix this, but it should behave something similar to like this. So let's go ahead and fix that bug, and then we'll start looking a lot nicer. So essentially, the problem right now is if you look at the third person character and you go to the character movement component, and I think it's called orient. Yeah, so there's a checkbox inside of here called orient rotation to movement. So let me just show you all of the settings just in case you're using something different. Let me just search for rotation. That'll probably pop it up. Right. So there's a couple checkboxes in here. So this is how it's set up right now, but when we attach to the wall, we want this guy to be unchecked because we don't actually want our rotation to be oriented to our movement because we want to be able to like kind of sidestep. So we want to actually turn this off whenever we start our wall hugging. So if we go into our wall hug component and we go into try begin wall hug, and then we go over here to the right, yeah, all the way to the right. So this is kind of what I was alluding to earlier. Let's actually unhook this. So there's two things we want to do here when we start wall hugging. We want to uncheck that checkbox. So to do that, we can just say get owning character, get custom, or what's it called? Get character movement component. And then we can have access to that checkbox. So we'll say set orient rotation to movement. And we want to set this to false. And then another thing we want to change is we want to actually slow him down because you'll notice when I'm up against the wall, my character is a lot slower. So inside of here, we can actually set the max walk speed. So we can say set max walk speed. And we can set it down to whatever you want. So the animations that I have, again, I'm pretty limited to animations. Like I'm not an animator, so I just get the ones I can from online. They're about moving at 100 speed, so I just chose 100. But if you have other animations that are faster or slower, you might want to adjust this value. And so we want to undo these values, obviously, when we end the wall hug. So let's actually write that end wall hug function as well. This will be a good time. So copy these nodes right here, all these nodes, do a copy, and go inside of the end wall hug function. So inside of here, we want to undo all of this stuff. So paste this, or paste these, and then also, before we do this, we want to set the wall hug state back to none, right? We're saying we're no longer wall hugging anything. So we can hook these guys up, like so. And then we want to do the opposite. So we want to set this to true, and then we want to set this back to whatever the default speed is of your character. Now, I just want to point out that this is probably not the best way to handle the speed, because if you were to, in your character, change his speed, and then you play the game, and then you wall hug, and then you unwall hug, if you just hardcode this to 600, it's going to set it back to 600. So you might want to do something where you like save the current walk speed before or when you start wall hugging. Like you just save it as a variable and then you reapply it here. There's a bunch of different ways you can do it to make it better if that's going to be a problem in your game. I just wanted to point that out. But for the sake of time in this tutorial, we're just going to set it back to 600. And the way I got 600 is it's just the default max walk speed. So if you click on the character movement component over here on the left and you search for max walk speed, you can see it's set to 600. So that's why I did that. So now we should basically see it work a lot better. So if I go up to the wall, I press E, you can see now my character is slowed down and he can only walk to the left or the right. And we should see that this wall thing works a lot better too, where he slides up over the wall and down, past the wall basically as needed. And then we can also start testing this with some curved walls. And then the last thing we'll do is we'll hook up the animation because I know it looks a little wonky right now. I'm just going to alt drag to make a copy of this. And let's just make sure our rotation stays correct when we're on a wall. So I'm just going to make a little curved surface here just so we have something to test. I guess a cylinder would have been a lot easier, but this will be good enough. So if I get on this wall, you can see hopefully, oh no, why is that not working? We must have messed something up. Let me take a look. Oh, you know what? We never actually wrote that code. Yeah, we never actually wrote that code. That'll be easy. So go inside the wall hug component, and we want to be inside of the tick on wall function, obviously, because we're going to do this while we're on the wall. So we did the location adjustment, which is good, but we want to do the rotation adjustment. So we're actually going to take this and just scoot it over a little bit because we want to do a sequence node here. So I'm going to hold down S and left click because we want to do both, right? We want to do the location adjustment to make sure his back is against the wall, and then we want to rotate him so he's facing away from the wall. So we're going to call set actor, or sorry, we need to drag in our owning character and say set actor rotation. And what we want to do here is we want to interpolate from whatever our current rotation is to our desired rotation. So our desired rotation is going to be, we're going to use the same function again. We're going to say make rot from zx again. And so just like I did before, our up vector, or our z, is going to be our up vector. So we'll say vector up. And our x is going to be the wall normal. And so this is the rotation that we want. And so we want to interpolate to it. We don't want to just instantly snap it. So we're going to use a function called r for rotation, r interp to. And so the current value is going to be whatever our current rotation is. So we'll just copy this guy and say get current rotation. Maybe not. Get actor rotation. Yeah, that's what it's called. And then this is our target. Our delta time, I think we have that up here. We have it, yep. So we'll say get delta seconds. And then for the interp speed, you can put whatever you want. Basically, the higher number you put here, I'm going to put 100. But basically, the higher number you put here, the faster he'll rotate to match the wall behind him. You don't want it to be too quick, because otherwise he'll just instantly snap his rotation. But you also don't want it to be too slow, because then he'll kind of clip through the wall. So 100 is probably a pretty good value. And then let's hook that up here. All right, so let's try this little corner thing again. I'm also going to add in a shape of a cylinder. And we're going to scale this up to make sure this works as well. Put it down right here. All right, so let's try over here first. So go up against the wall, and then we start walking, and you can see he's interpolating very quickly. We probably, what did we mess up? Oh wait, I actually had 10 in my other project, not 100. So you can see that's what it looks like if you have a high interpolation rate. So let's try 10. So we should rotate nice and smooth. There we go. Nice and smooth rotation as he moves along the wall. S doesn't seem to work for some reason. Why does S not work? Did we mess something else up? Let's see. Let me go to my handle movement input. If scale is less than -0.1 in the wall hug, I should definitely be getting called. Oh, I know why. So I'm just gonna add a F9 breakpoint here. Let me make sure this is getting called and then we'll fix it because I think I have the problem. So I press S. Okay, so this function is getting called. So the reason we're not actually getting off the wall is because the third person character doesn't actually know. Third person character doesn't actually know that we're ending the wall hug. So what we need to do here is we're gonna actually make an event dispatcher. So just add a little event dispatcher and call it on wall hug end. And then inside of here, our end wall hug, we're actually just gonna dispatch this. So we'll drag this in and say call. And so then this event is gonna get dispatched whenever we finish the wall hug. And that way the character blueprint can know about it. So if we go to our third person character blueprint, we actually want to do this in, let's see, I think we want to do this in the begin play is where I did it before. Yes. So go to the event graph and go up to the top. If you don't already have a begin play, you'll have to right click and add one. But basically we want to bind to that event so that way we know whenever the character stops a wall hug, and that way we can set our movement state, right? Because we need to set our movement state back to default, so that way we can start walking again. So all we need to do is drag in our wall hug component and say assign or say bind to on wall hug end, and then we'll just say drag off this guy and say add custom event, and then I'm just going to call this on wall hug end, and then in parentheses, I'm going to put bind just so we know it's a bind event, and then we'll set it back to default. So again, we're just binding to this event, so whenever it gets called, we'll set our movement state back to default. And so now it's giving me an error. What do you want? Blueprint failed to compile. Yes, but why? Oh, I guess it went away, I guess. Okay, I guess the error went away. Okay, so let's try this again. So we should be able to come over here and go up against the wall and press S. Okay, there we go. So now we actually come off the wall, and then we can do it again, and we come off the wall. Perfect, okay. So let's try this again. So, oh, we already tried this. So this works, and we can come off the wall, and then let's try this guy. So you can see how our character is always facing away from the wall, which is good. Okay, so now we pretty much, I think we just need to do the animation side of things next, and then we'll be good. One other thing I forgot is down here, when we hit the wall hug key, we mentioned this earlier, but if we are already on the wall, then we want to stop it. So let's move this over. So that way we can press E to get on the wall, and we can also press it to get off the wall. So to get off the wall, we just drag in our wall hug component and say end wall hug. Or no. Wait a minute, that's not right. This needs to be public. This end wall hug function, I made it private. This needs to be public. Let's drag it up here to the top of the other public functions. And same with this one. Okay, so these three should be public, the rest should be private. And so back over here, we want to make sure again to call on or end wall hug. There we go. Make sure you get the right one here. So if you search for end wall hug, you'll see these are all related to that event dispatcher we added. We want to get this one, the one that's specifically called end wall hug. So now we should be able to press E to get on the wall. And then if I press E again, we should now technically be off the wall. So if I would just press A, you can see it walks off the wall. Okay. It's a little hard to tell because we don't have the animations hooked up yet, but now E is actually taking us off the wall. Okay, so the last thing we need to do is the animation blueprint, which I think is actually going to be pretty simple here. So let's go to our content folder, or where is this guy? I guess the easiest way to find it is to click on this guy, click on his mesh, and then in the details panel for his mesh, we have an animation class. If I hit this little magnifying glass, it'll bring me to the animation blueprint that he's using. So let's open this guy up. So at the very beginning, we already made the animation blueprint for this, so it's going to make it a little bit easier. but there's some values that we're actually going to need in order to get this thing to play. So let's go to the event graph. I need a drink. Hold on 1 second. Okay, let's go to the event graph here, and I'm actually going to take this value and save it at the beginning to make things easier for us. So we're just going to say event blueprint begin play. And then let's take this guy, so copy and paste. And we know that this is going to be a third person character, so we can just say cast to a third person character. And then let's just promote this guy to a variable. Click on this guy, we'll make him private, and we'll call him our player. So that way we don't have to do this everywhere and continuously check if it's valid. I hate the way they have this set up by default. It's so ugly looking. So we can actually just delete this. Drag in our player, say get, right click, convert to validated get. And then hook this up. And then I'm just going to drag this guy to here and to here. That's how it was before. So now there's a little less lines going everywhere, but now we have access to our player. So we want to be able to get the movement state from our player. And so if we drag in our player and we search for get movement state, you see it doesn't show up. And that's because we made that variable private, which is good. It should be private, but we want to be able to have access to it. So let's just make a little function real quick to get access to it. So let's go back over here, make a function and call it get movement state. We can make this pure and const since it's just a simple little getter. We'll drag in this guy and say get, and then drag this up here and then over here. Just like that, we have a little getter for our function or for our variable. And we can come back to our blueprint, and now we can say get movement state, and there's our function. And we want to save this into a variable, so promote to variable, hook that up, and we'll make this guy private as well. And so we're going to be able to use this movement state to switch between our animations, right? Because if it's none, then we're going to use the current animations that are there. But if it's set to on wall or wall hugging or whatever we called it, then we are going to use our blend space that we created for the wall hugging. And then the other thing we need to look at here is the direction that we're moving in. Because if we're moving left, we want to play obviously the left animation, and if we're moving right, we want to play the right animation. If you remember from our blend space earlier, if we just open this guy up, so we have it set up so that if we pass in -1, it plays this guy on the left, and if we pass in +1, it plays this guy on the right. And obviously if you pass in 0, it just has them idle. So we need to come up with that value of -1 to +1, and so we can figure out what to pass to this blend space. So we can actually use the dot product for that. And again, if you don't know what the dot product is, go check out my Game Math Essentials video on my channel, and it explains that in detail. But it basically gets the likeness of two vectors, like how close they are to each other. So if you take the dot product of two vectors and it returns 1, then that means they are perfectly aligned and they're facing the exact same direction. If it returns 0, it means they are perpendicular to each other. And if it returns -1, it means they're facing in the exact opposite direction. So we can use that knowledge to come up with this direction value. So what we want to do is we want to drag in our player, and we want to say get velocity. And then if we normalize the velocity, it'll give us essentially the direction that we are moving in. And if we take that and we dot it with our character's right vector, so get actor right vector, this will give us a value from -1 to +1. So I'm just going to print this out so you guys can see it real quick. It'll make a little bit more sense when you can actually see it. So we'll just print this guy out, set this down to 0. And so, wait, could not find function. I might have to just refresh this, or I might have to compile. Sometimes you have to compile for it to be happy. Okay, so all I'm doing is just printing out this dot product result. So if I'm on the wall and I'm walking left, it's 1, and if I'm walking right, it's -1. And it doesn't matter what the surface is, or like which direction the surface is. You can see it's like -0.99999. That's basically -1 when I'm going right, and it's +1 when I'm going left. So no matter what angle the wall is at, this is always going to be the case because I'm comparing my character's right vector to the way I'm moving. And again, if you don't understand this, just watch that game Math Essentials and it will make a lot more sense. Okay, so we don't actually want to print this out. We want to save this. So right click, promote to variable, and we'll call this direction. Maybe we'll call it like, oops, I just opened a window on my other screen. Sorry. Let's call this wall hug direction just to be a little bit more specific in case direction is too vague. And so we can hook that up. So now we have the movement state that we're in, and we have the wall hug direction. We could actually, if we want to be, if we really want to, we could do a switch statement here and only do this if we are wall hugging, because otherwise we don't really need to calculate this value because we're not actually on a wall, so it doesn't matter. So this is probably a fine thing to do. And then lastly, I think we just need to go into our animation graph here and then go into our default state machine. And we want to hook up our BS wall hug. So let's drag this guy in. And where we hook this up? Well, we only can begin wall hugging if we are, in this idle/run/walk state. If we're jumping in the air, we can't actually begin a wall hug. So we really only need to hook it up to this guy. So if we drag from the wall hug, if we drag from the idle into the wall hug, it will create a node, and then let's also do one back. So this is the transition node. So like the rule that tells it when it can go from idle running into the wall hug. So if we double click on this guy, the rule is, well, you can transition if the movement state is wall hugging. So if we drag in our movement state, we can say equal, and we want to use this enum one, so we'll have a drop down. So if it equals wall hug, then go ahead and return true. And we want to do the opposite for the one on the way back. So we want to say, movement state. We want to say if it does not equal the wall hug, then we can go back. All right, so let's give this a try. Hopefully it just works. So if we go here, you can see our character turns back to the wall, and he's now in his idle wall hugging animation, and he doesn't actually move. Oh, I know why. So inside of here, double click on this guy, we need to actually pass in our direction, right? So pass in our wall hug direction into here. And now he should actually play the right animation. And there we go. Now, one thing I noticed about this animation is it's pretty far away from the wall. And unfortunately, I'm not an animator, so I'm not exactly sure how to edit this animation so he'd be more back towards the back. But one thing you can do to fix this pretty easily is inside of the third person character, you'll notice his capsule is actually pretty freaking big. I mean, there's a lot of things you can do to fix this. You could slide this back, but then he'd like always be back that far, and maybe you don't want that. You could do that programmatically as well, but an easy fix is just making the capsule something like 36 radius, so he's like fits more precisely inside the capsule, and that makes it a little better. Again, I just have to deal with animations that I get from the internet, so I can't like really adjust animations because I'm not an animator. But you could always scoot him back a little, or you could like move him back only when he gets on the wall. But yeah, that makes it look a little bit better. But just know that that's adjusting like his capsule in all states. But if you're an animator or you have better animations, you could probably get them more precise up against the wall, or maybe you know a better way to do it. If you do, feel free to leave it in the comments. But yeah, oh, we forgot one other thing. So we forgot the ledge case. So in the case where, let me just, because this is important. So in the case where you are up on a ledge, just try to show you this, like so. So if we were up here and we were wall hugging, and we fall off the wall, maybe you want him to continue wall hugging, but I think it's a little bit weird if he's just doing that as he falls. So an easy way to fix this, super easy way to fix this, if you go to the event graph, there's actually a function you can override called onWalkingOffLedge. So this gets called when your character walks off a ledge. And pretty nifty. And so all we want to do is say, let's see, let's drag in our movement state, and let's check if we are currently wall hugging by a switch statement. And if we are, then we'll say get wall hug component, end wall hug. Basically saying when we walk off a ledge, if we are currently wall hugging, end the wall hug. So now let's see, we come up here and we walk off the ledge. He switches to a falling animation. But you'd also notice if this was a lot shorter, if this was a lot shorter and it was actually something he could walk off of without falling, then he won't end his animation. He'll just nicely walk off of it. And let me make sure this works real quick. Yes, it does. Okay, so I think we're actually good. So if you want to turn off those lines, you can do that inside of the BP wall hug component. If you go to the line trace function, just set this to none, and then you'll get rid of all these lines that show up. But anyways, that concludes the tutorial. If you guys liked the video, I'd appreciate a like and subscribe. I also have a Patreon if you guys want to support me there. That's always appreciated. And I also have a Discord. The link to all that information is in the server. If you guys want to join the Discord, feel free. Anyways, thanks for watching, and I'll see you guys in the next video.